Tutorial 1, 2, 3, based on chapter 1, 2, 3, I think, and 4. So these are all the things that are being used. So yeah, you can just head back to your tutorial to see the answer. So I'll not go through this, but however, two things that I'll go through. First thing is very straightforward. This one is a DC supply. Okay, it's a battery, so it's a DC supply. Everything here over here is DC supplies. Okay. Comparatively, if you were to see this logo, it is an AC supply. Okay, so if you were to see AC supply, you're going to see the inductor, capacitance all come in. And then the calculations wise, you have to first find the impedance. I think inside the paper you see. So I'm not going to go through this. And then, most importantly, this video is trying to talk about this thing. Okay, so how do we simplify the circuits? So, if you were to take a look in question 1, these are the things. But what if they give you something that is like this? You have to simplify this again, right? So the purpose of this video is to simplify a few really tricky questions. So the first one, I actually have a rule. Okay, the rule is that so this is the thing: number of path split is equals to number of parallel connections. So what does this mean? Okay, the number of path split. Let's take for this one. This is the point where it splits, right? It splits to two portions, and when it comes in, this is the point where this when this line meets with this, right? This is the point because current flows in this direction. I see. Currents flow in this direction, right? You're gonna flows, and it flows in here, and it flows in here. Until here, it flows in this directions, and this one will flow all the way down, right? So at this point they split, at this point they meet. So this is the rule that I'm gonna use for these two circuits. Okay, this two. As for this one is yeah, different. But anyway, so yeah. So how do we simplify this circuit? It's pretty much wow, you know. So the first thing first, there's only one rule. Wherever you split, this is the number of parallel connections. So we can just follow where it splits. Okay. So I just follow the trend. So when I'm moving over here, in this direction, this is my thing. I have this one, right? And then at this portion over here, I split, right? I have split. So I'm going down this portion, and then I have another one going in this direction. So and up to here, I have a connections that is going in this in these two directions, right? Yeah, so they actually split in these two directions. So this is the point, this is the second point. Okay, maybe I should indicate in a different color. Okay, this is the second point where it splits, where this point splits and go in the direction when they meet at this portion again, right? So at this point, I'm gonna split up, right? I split into two directions, one going here and one going here, right? Then you may wonder why this one don't comes in. Okay, I also don't know, but that's because this breaks. This point splits earlier than this point, right? So definitely you'll go in this direction all the way. You'll go all the way down. Okay, that's what but it's not a good explanation. Okay, never mind. So let's continue. But yeah, this is the only way that I can find out to explain. So yeah. So once you do this, so this is the point where I'm talking about. So this red line is this one, right? So in other words, they split at this point. So at this point they split and they go this one go in this direction and this one go in this direction. and then they meet up with this dude over here. Maybe I should erase the stuff. Maybe I should, yeah, anyway. So, and then they meet up with this dude over here, right? This is the point where they meet. They should indicate in the cross, right? Then they go, and then they go in. So this is the thing that you can simplify. Okay, if you don't know what I'm talking about, you just click back to the first part and then you just rewatch again. I'm not gonna repeat, but just to take note, there is 2 points, okay, 2 splitting points. One splitting point, this dude go over in this direction, this dude go over in this direction. And then when this dude go into here, it splits again, it splits into here and it splits into here. Okay, and it goes, yeah. But however, you may ask why this dude didn't split into here, because I don't know. Yeah, but anyway, it is a pretty decent thing. Yeah. So the second one is this one. Okay, it's the same thing. Where do we split? So you know that the current is going in this direction. So it comes here. It splits into 3 paths: 1 point, 2 point, 3 point. Right. So from this here, you can see that there is one line over here. Okay, maybe I should redraw again. So this thing is going in this direction. So I'm drawing in this direction. Okay, and then at this point, this dude is coming in, right? So we have a resistor, and then I have another one that's going in this direction and going here. So I have another one splitting at this point. This is the point where they split, right? This is the point where they split. And then I have another one, and then it comes all the way down, right? So I have the point where they meet over here, right? These are the 2 points that they split and meet. Okay. Maybe I should indicate a cross over here. Maybe a crossover down there. Yeah. Okay. So yeah, sorry. And then I have a thing like that. And then I have a simplified circuit. Okay. For this one, I think you already know. I mean, no, not know, but rather than yeah. So I'll just zoom in a little. This is the question. Okay. So how do you simplify this question? It's in fact a series circuit. Okay. It's connected in this series. That's all. Okay. Yeah. And then this one is just a T circuit. I think this one is pretty easy, but this one is a series actually, so be careful with it's like a trick question. So yeah, I hope I made this clear. And then the last one is a little more tricky. Okay. This type of thing instead of this one, okay, it's a little different. It's in between, they actually, connected. So what can we do about it? What can we do about it? One way is to so in this situation you cannot use the previous rule. Okay, number of path splits equals number of parallel connection. Okay, this is not from any internet source. This is how I observe and I spawn. Okay, so at a certain aspects I may be wrong. Yes. Yeah. Anyway, so the solution that I sourced from the internet is that this one, you can actually bring this out of the circuit. Okay, so you can, so in other words, this dude over here, this line, you bring it out over here, and when you bring it out over here, you're gonna divide this 2 by 6 by this thing. So this explains why we have 2 and we have 3 over here. Okay, and with these, you know that this is parallel, right? So I repeat again. Okay, I repeat again. I think you already understand, but let me repeat again. So this 6 ohm, okay, this 6 ohm, because from the previous one you cannot draw any circuit, right? Because you split over here, you go in this direction. There's 1 ohm over here, right? You split over here in this direction, and then another is over here, right? But however, at this point, you're gonna merge with this dude over here, and then you have another split path that meets up, and then go into another life. So this is the point where it's a little tricky. Okay, you may say that this is about the same as this one, but I don't know, But anyway, so the only solution that I could see is that this one, you can bring it out over there. So you have this. So this is what the internet has provided to me. So with these, um, but when you bring the 6 ohm out, you're gonna divide the 12 and the 18 because, um, it's yeah, whatever. Hold on. Maybe I would think that this one is actually stating what the 12 ohm and the 18 ohm shares. Okay, they are in the same they share the same current or whatever lah. What I'm talking. Anyway, you just bring the 6 ohm out over here and that's it. And then yeah, and then if you were to simplify this one, you'll get like that. And then okay, so you have a parallel circuit. So this one I think you know is this one. Okay, and then this one, it's this one and this one, right? And then this one is this one. Okay, and then I have a finish ending. Okay, so these are the things that hopefully can give you an intuition on analyzing a DC circuit and simplifying it. Okay, nonetheless, if it's AC circuit, if the inductors are connected in if the inductor or capacitor is connected in this ways, at least you know how to um, deal with it. Okay, and the last thing is from your slide 2, okay, week 2 lesson. Remember this one, because if you remember this one, then you can know how to deal with all these things already, because once you simplify it, you also need to memorize how the capacitance are being added up or whatsoever. So these are the things you may need to really go and take note. Okay, and then I'll try to spawn out a time to actually do out this one. Okay, how voltage, current are being measured, and what are the things in order to measure resistance or what. These are the yeah. And then slide 3, week 3, you're gonna talk about all this sensing techniques. I also haven't got no time. So in the next video, I'll talk about the rest. Okay, chapter 5 and 6 for the tutorial. So at least I can retain what I have learned for the past few days. So I'll see you in the next video.